শুভজিৎ, স্বস্তিকা, শরম।
Good morning, Shastik, Shubhodip. Good morning. Please tell other to join. Shubhodip, please tell other to join. Good morning, Shastik. So, first I state the Cochrane theorem. Good morning. Shututi, good morning. Shututi, is it your first class? Shututi, are you hearing me? Is it your first class to attend? Okay. Why? Why not? Which group? Okay. So if you have any doubt, please go through the previous classes. This is the last class of linear model. So Cochrane's theorem let Euclid follow IN is the identity matrix of. Okay, thank you, Shruti. So Euclid follow n-dimensional multivariate normal with zero mean vector, and IN is a dispersion matrix. IN is the identity matrix of order n. If a quadratic form, good morning Shubhodip, if a quadratic form Euclid prime n Euclid is expressed as move her I from 1 to k, u curl prime mi u curl, and m is idempotent matrix. Any one of the following conditions implies the other. Mi square equal to mi, that means mi is a idempotent matrix. Mi mj equal to null matrix Yes, Shashwati, good morning. And rank of m is rank of m1 plus rank of m2 rank of m2. Now this A implies, since if Mi is idempotent matrix, we know from result of multivariate normal u curl prime Mi u curl follow chi-square distribution with degrees of freedom rank of Mi. We know this result from multivariate normal. And this condition B imply any two component u curl prime Mi u curl and u curl prime nj u curl are independent. So this is another well-known result of multivariate normal. This is known as Kendall and Stewart theorem. This theorem says two quadratic form u curl prime m1 u curl and u curl prime m2 u curl in normal independent variables u curl with common variance sigma square are independently distributed if and only if m1 m2 equal to null matrix. So this is the statement of Kendall-Stewart theorem, and if you use this theorem, then we say that any two component of u curl prime mi u curl and u curl prime mj u curl are independent. So condition 2 implies u curl prime mi u curl and u curl prime mj u curl are independent, and condition 1 implies u curl prime mi u curl follow chi-square with degrees of freedom rank of mi, and condition C imply the degrees of freedom of the MIs add to the degrees of freedom of M. So this theorem, this Cochran's theorem, states that if condition A is true, then B and C follow, C also true. Similarly, if B is true, then A and C true. If C is true, then A and B true. So if you prove any one of these three, automatically other two imply. Okay. So for example, so mainly we use this theorem to prove the result of ANOVA. Suppose in ANOVA actually we split the total variation SST, sum of square due to total variation, which is written as I from 1 to n yi minus y bar whole square and this is nothing but a curl prime a y curl prime a y curl, where a is this. Clear? I think it is better to consider ANOVA model first. So suppose I consider one-way ANOVA. Yij mu plus alpha I plus Eij I from 1 to k. Suppose k is a number of groups or level of factors, etc. Or you can k is a number of treatment if you consider complete randomized design. So and j is number of observation under ith level of a factor. Suppose I consider factor A and it has a k level, then under ith level there are ni observations and n is a total number of observations, which is nothing but a sum over I from 1 to k. So here we know SST, sum of square due to total sum of square, so which is equal to I from 1 to k j from 1 to ni yij minus y bar whole square. Y bar is grand mean. We generally denote by y bar double dot yij. This is j from 1 to ni and I from 1 to k. So this is equal to sum over I from 1 to k, sum over j from 1 to ni yij square minus ny dot dot bar whole square, which is y curl prime y curl minus n y curl prime 1 1 prime y curl, where y 1 curl is vector with whose all elements 1 of order n cross 1. So this is nothing but a in is identity matrix. So I think it is better to write 1 suffix n. This means a vector with all elements 1 of order n cross 1. We can easily check that this is a idempotent matrix. I denote this by n. This is the idempotent matrix. So rank of m is nothing but a trace of m. So trace of m is n into 1 plus, because all diagonal elements of a matrix is 1 minus 1 by n. So this is nothing but n minus 1. So this is, we know, total degrees of freedom. Now SSD2 between group, which is equal to sum over I from 1 to k ni yi naught bar y naught naught bar whole square. This is equal to this is equal to where yi naught bar equal to 1 by ni sum over j yij, and this is written as yi prime 1 ni. 1 ni is a, I already defined this vector. This is a vector whose all elements 1 and its order is ni cross 1, and we partition vector y curl as Okay. This is y1 curl prime, y2 curl prime, yi curl prime, yk, yk curl prime, whole prime, where yi curl is yi1, yi2, yin, yini. Okay, so yi dot bar is nothing but a yi curl prime y1 ni by ni, or this is same thing. Okay, so now this is equal to root over n1 y1 dot bar root over n2 y2 dot bar root over nk y k dot bar so this portion written as follow. So I denote this by W1, W2 and WK, and then this is nothing but a W curl prime W curl, where Wi is root over ni y I dot bar I from 1 to k, and this portion, we write this portion y dot dot bar is nothing but a sum over ni yi dot bar by n. So this is I think it is better. Okay. Alright. So again this is W n1 y1, that means we write this as n1 y1 dot bar into y2 dot bar. So I write this part as w star prime 1, where w star is equal to n1 y1 dot into y2 dot no okay it is better to write this part as root over n y dot dot bar whole square root over n y dot dot bar. Okay, so not whole square, y root over n y bar dot dot into root over n. So now root over n y dot dot bar is nothing but a w curl prime 1 curl, clear? Because you see that w is our root over n 1 y1 dot bar root over n2 y2 dot bar root over n k yk dot bar. So again we write this portion as, please check this thing, w curl 1 prime w curl not necessary, this is a scalar thing, 1 curl prime w curl. So again we write this matrix, this quadratic form as w curl m1 w curl. So please find m1, which is nothing but a complete symmetric matrix, or check that. I think it is not a complete symmetric matrix, because please check, find m1, check is it a complete symmetric matrix, is it a complete symmetric matrix, and then see that this m1 also idempotent matrix. These are your homework, idempotent matrix, and hence find rank of m1, which is nothing but a rank of trace of m1. I assume this is a complete symmetric matrix, m1 is a complete symmetric matrix. Your job is prove that this m1 is a complete symmetric matrix. So, and then you see that this is nothing but a k minus 1. Rank of m1 is equal to trace of m1, which is equal to k minus 1. So this is your homework. Okay, so please find it. Now SSB SSE, sum of square due to error, this is So you can easily write this portion ni yij minus yi naught. This is simply as, just see the SST, expression of SST. So this is okay. We write this thing as follow, which is yi curl I ni minus 1 by ni 1 ni curl 1 ni curl prime yi curl. So this portion is I think it is better to denote this matrix by Ti. Okay, and this summation of Ti, so this is nothing but a 1 from 1 to k yi curl prime Ti yi curl. So and we can easily see that this Ti is a idempotent matrix and rank of Ti equal to trace of Ti, which is equal to ni minus 1. Okay, so this summation Ti so now SSE, this is equal to y1 curl prime t1 y1 curl plus y2 curl prime t2 y2 curl yn curl prime yk curl prime t yk curl. So using Cochrane's theorem, this SSE, if you write SSE equal to y curl prime m2 y curl, so using Cochrane theorem, m2 equal to t1 plus t2 plus tk. Okay, and rank of m2 is nothing but a, using Cochrane theorem, rank of Ti, and hence rank of Ti equal to ni minus 1 I from 1 to k. So this is n minus k. So error degrees of freedom is n minus k. And another homework is you should check this thing m equal to m1 plus m2, where m1 is this and m2 is this. So first thing is you should find m1, then check that m1 is a complete symmetric matrix or not, then find m1 is whether m1 is idempotent or not. My guess is m1 should be idempotent. Then find rank of m1. If it is idempotent, then rank of m1 equal to trace of m1, and if it is complete symmetric, then you can easily see that then this trace is nothing but something into constant, then it is k minus 1, check that this rank of m1 is k minus 1, and again next you find m2 can written as we see already, we see that m2 is a sum of k complete symmetric matrix, and your job is find simplified form of m2, and then find and we see that rank of m2 is nothing but a sum of the rank of ti, and sum of the rank of ti is nothing but I from 1 to k ni minus 1. We already see that rank of ti is ni minus 1, hence rank of m2 is n minus k. So and you can also find rank of m2 directly. If you find the simplified form of m2, then you see that m2 is idempotent matrix, and rank of m2 is rank of m2 is rank of trace of m2, and it is n minus k. So this is your homework, and you see that here m1 and m2, these two are idempotent matrix. So using Cochrane's theorem, m1 m2 0 null matrix, this condition also satisfied. Just you need to show that m1 and m2 idempotent or not. I think it is easy to see this thing, m1 m2 idempotent. If you see this thing m1 m2 idempotent, then m1 m2 are equal to 0, it is automatically followed using Cochrane's theorem, and rank of m equal to rank of m1 plus rank of m2. If you see that here n minus 1 equal to n minus k plus n minus k is a rank of m2, and rank of m1 is k minus 1. If you prove this thing, then you say that m1 m2 both are idempotent and m1 m2 equal to 0. So either you show that the rank of m equal to rank of m1 plus rank of m2, or if you find m1 expression of m1 m2, then you if you prove that m1 m2 are both are idempotent, then 2 and 3 are automatically followed. So if you find the form of m1 m2, and if you find m1 m2 are idempotent, then you can easily then this thing is automatically followed, that using Cochrane's theorem and result of multivariate normal distribution, this SSE follow chi-square distribution with n minus r degrees of freedom, because in the Cochrane's theorem I assume that variance is 1. If variance is sigma square instead of 1, then you just need to add multiply sigma square here. And SSB, this is also follow chi-square with k minus 1 degrees of freedom into sigma square under h naught, because under h naught this is yi under h naught, yi bar are IID normal mu sigma square by ni by yi actually under h naught, otherwise under h naught yi follow, because SSB involve these portions. So under h naught SSB follow chi-square with k minus 1 into sigma square, otherwise this is a non-central chi-square chi-square with k minus 1 degrees of freedom. This is also from the result of multivariate normal distribution. These are automatically follow. Just you apply Cochrane's theorem. First you find, either you find m1 m2, actually among these three conditions, which is easier to compute. Suppose you find m1 m2 mk, and you can easily see that mi's are idempotent matrix, then automatically 2 and 3 are follows, and using multivariate normal, result of multivariate normal distribution, you can find the distribution of different quadratic form. Okay, this is the utility of Cochrane's theorem. So please tell me if you have any question or query. Shubhadeep, Shututi, Shohini, please tell me if you have any queries or question regarding Cochrane's theorem, application of this Cochrane's theorem, or regarding homework or assignment. Please tell me, I can explain again. Shashwati, tell me. Shubhadeep Mujumdar, Shubhadeep Gain, tell me. Shubhadeep Chakraborty, regarding assignment, have you any difficulty? Have you any problem? Actually, first your job is find m1, okay, expression of m1, then find whether m1 is idempotent matrix or not. Next job is find m2, whether m2 is idempotent matrix or not. If m1 and m2 both are idempotent matrix, if you find the rank of m1 or rank of m2, whatever that, then you can easily find rank of m2 using third part of axioms, third part of Cochrane's theorem. And since m1 m2, if m1 m2 both are idempotent, then automatically 2 holds, that is m1 m2 equal to null matrix. Hence, using result of multivariate normal distribution, you can say that SSC and SSB both are independently distributed, and SSC and SSB both are chi-square distributions. Okay. So please tell me, Shubhadeep, Shashwati, Shututi, Shohini, have you any doubt? Please tell me. Can I wrap this portion? Are you hear me? Please let me know. Please tell me if you have any doubt, any queries. Okay, Shashwati. Next, fundamental theorem of F test. So this is the model. assume a independent estimable parametric function this means y curve follow multivariate n-dimensional multivariate normal its mean vector this, and this is a dispersion matrix. And we already know that this is sum of square due to error. I denote this by SS suffix e, which obtained by minimizing this part with respect to theta. And in my previous class it was seen that SSE follows sigma square chi square with n minus r degrees of freedom, where r is a rank of A. Now I define S1 square, which is equal to minimum over theta curve, not only theta curve, another restriction I introduced, that is h prime theta curve equal to xi. So if it is this part is minimized with respect to only theta, then it is nothing but SSE, but here I introduce another constraint, that is h prime theta curve equal to xi curve. So S1 square is minimum value of this, with this minimize this value with respect to theta, and another condition h prime theta curve equal to xi curve. So this SS1 square is called conditional error SS. So this is a unconditional. Sum of square, unconditional sum of square due to error. Why it is conditional? Because this condition. So this S1 square, because of these restrictions, should be greater than equal to SE, and SS H naught, if you assume your H naught null hypothesis is H prime theta curve xi, so sum of square due to H naught is nothing but a S1 square SSE. So this difference contributes sum of square due to H naught. So, and we want to prove that this portion follow chi square with k degrees of freedom. This is a non-central chi square distribution. This is a non-central chi square distribution with degrees of freedom k and lambda is non-centric parameter. N for NCP, non-centric parameter, and this lambda equal to 0 under H naught. So this is the first part which we want to prove. This is the second part which we want to prove, and the third part, SS under H naught by K by SSC n minus K. This follows non-central F distribution with degrees of freedom K minus 1 K n minus K. Sorry, this is not n minus K, this is n minus R. Okay, so this should be n minus R. And under H naught, this ratio follow F distribution, central F distribution with K n minus K degrees of freedom. And we know we reject H naught if this F ratio, that means this portion SS H naught by K by SSE n minus K. SS H naught by K, we denote this by MS H naught, mean sum of square due to H naught, and this is mean sum of square due to error. This greater than F alpha K n minus K. So this is a upper alpha percentile of F distribution with K n minus R degrees of freedom. Okay, this is R. K n minus R degrees of freedom. Now it is given that H prime theta curve is estimable, and we know if H prime theta curve is estimable, then HI curve, HI is a ith column of H matrix and order of H is P cross K. Belonging to column space of A prime A. And we know that the blue of Hi curl prime theta curl, this is from the previous result, we already proved this result. So the blue of Hi curl prime theta curl is Qi curl prime A prime Y prime. And we know this qi curl, the order of qi curl is p cross 1 is a vector satisfying A prime A qi curl hi curl. We know this result, okay? So the blue of h prime theta curl is equal to we write this h prime theta curl as and the blue is h1 curl prime theta curl is q1 curl prime a prime y curl. This is q2 prime a prime y curl is a blue of h2 prime theta curl. Similarly for hk prime theta curl, the blue is qk curl prime a prime y curl. Hence where Q is a matrix of order P cross Q. So Q curl prime A prime Y curl is a blue or rather it is, you can say that blue of h prime theta curl is q prime a y curl, a prime y curl. Now AQ contains k independent vectors which are linear combination of columns of A. Why AQ contains k independent vectors? Can you tell me? Can you tell me why I write this statement? Because this h1, h2, hk all are linearly independent vectors, because I mentioned in the statement that h prime theta curl is linearly independent estimable parametric function. So we know the result using the previous result. So this qi prime a prime y curl and qj prime a prime y curl are uncorrelated. Therefore, a q contain k independent vector. So the order of this AQ is n cross k independent vectors which are linear combination of the columns of k. So that means AQ, columns of AQ all are independent, and since this is estimable, so the columns of AQ should be written as a linear combination of A. Clear? Now columns of A, rank of A equal to R, and this R greater than K. For this reason we can choose a n cross R minus K matrix D such that its column are orthogonal to each other and also orthogonal to the columns of AQ. So this is always possible. First procedure is, first you find the R minus K independent vector from the column space of A, and then using Graham-Smith orthogonalization technique you find orthogonal, make this vector to orthogonal, convert this vector to orthogonal vector, and we can construct D matrix using this orthogonal vectors. Okay, so this is the procedure. I actually in my linear algebra class I already discussed several times how to construct this additional vector such that we can get a basis of superset, or basis of a larger subspace. So the columns are to each other and also orthogonal to the columns of AQ. Therefore, AQ D forms a basis of column space of A. Let G of order n cross R be as before, means just the previous result of previous class where I proved this result. SSC follow chi-square degrees of freedom. In that proving in this proof part, we also we introduced G matrix. Similarly, here I also introduce G. That's why I write let G be a matrix of order n cross R as before. We transform for y to z as z1 curve is equal to aq prime y curve. This is equal to q prime a prime y curve. So this part is a blue of h prime theta, and another vector z2 which is g prime y curve, and z3 this is d prime y curve. So this z is nothing but a z1 curve, z2 curve, z3 curve. As a whole, this is a vector of order n cross 1, and z1 curl is q prime a prime y curve, z2 curl is g prime y curve, z3 equal to, since z3 equal to d prime y curve, so this is nothing but a q prime a prime g prime d prime y curve. I denote this matrix by W. So W prime, so Z curl is nothing but a W prime y curve, where W is equal to AQ GD, and we can see that this is a non-singular matrix. Why this is a non-singular matrix? Because this portion is nothing but a column space of A, come from the column space of A, and this portion AQD forms the basis of the column space of A, and G is a matrix, and this belonging to the error space. So this whole thing is n cross n, and the columns of W gives the basis of Rn. Therefore, W is a non-singular matrix. You can easily see this thing. Please verify. Okay. Note that G prime A Q 0, because we choose D matrix such that columns of D is also orthogonal to the columns of AQ. Hence, this thing is satisfied. G prime D, this is again 0. So this is from the you can easily relate this part with the result that SSC follow chi-square distributions. So D prime AQ, this is again 0, because this and these are forms the basis of column space of A, and G belonging to since G belonging to the error space, and this part and this part are forms the basis of column space of A. Hence, these are 0, and from this portion we can say that D prime AQ equal to 0. Therefore, y minus a theta prime y minus a theta, which we write this portion as since z equal to w prime y curl, and since w is a non-singular matrix, so y curl is w prime inverse z curl. So therefore, w prime inverse z curl minus a theta curl is nothing but expectation y curl, which is w inverse w in prime inverse z curl prime w prime inverse z curl expectation w prime inverse z curl. Okay, so we write this as z prime expectation z curl minus expectation z curl prime w inverse w prime inverse z curl minus expectation z curl, and this is again written as the expectation z curl minus expectation z curl prime w inverse z curl minus expectation z curl. Now, expectation z curl equal to expectation z1, expectation z2, expectation z3, and expectation z1 is nothing but a expectation q curl prime a prime y curl equal to q prime a theta curl equal to this matrix is nothing but a h prime theta curl equal to xi curl, under H naught. And expectation of Z2, this is G prime expectation Y curl, G prime A theta curl equal to 0 curl, and expectation Z3, D prime Y curl, D prime A theta curl. And since Z's are linear functions of Y curl, which is normally distributed, each of Z1 curl, Z2 curl, Z3 curl are normally distributed. So therefore, Z1 curl, which is order k cross 1, Q prime A prime Y curl, just using result of multivariate normal distribution, this follows H prime theta curl, since expectation of H, the expectation of Z1 is H prime theta curl, and the dispersion is sigma square Q prime A Q. So this is the well known, you know this result, this is the well known result of multivariate normal distribution. And Z2 curl, which is G prime Y curl, this is follow normal n minus k dimensional multivariate normal with mean vector 0 and dispersion matrix sigma square D prime G prime A G prime G. So this is equal to sigma square n minus r, and Z3 equal to D prime Y curl normal with r minus k, multivariate normal with multivariate normal r minus k dimension with mean vector D prime A theta curl, and dispersion of D prime Y curl is sigma square D prime D. Since I construct this D matrix using orthogonal vectors, so D prime D should be I r minus k. So therefore W prime prime a prime g prime d prime aq gd. You see that this is q prime a prime a q, q prime a prime g, q prime a prime d, 0 matrix. Identity matrix of order R, 0 matrix, 0, 0 matrix I R minus K. So this Z prime expectation of Z this is Z1 minus H prime theta curve Z2 Z3 A theta curve then y minus a theta curve prime y minus a theta curve. This is z1 minus h prime theta, z2 curve, z3 curve minus d prime a prime, d prime a prime, d prime, d prime a theta curve and q prime a prime a q, q prime a prime g, q prime a prime d, I n minus r, I r minus k. Yes. So this is nothing but a since this portion is 0, just see this result. This portion is 0, this portion also 0. So inverse of this is nothing but a inverse this. Okay, so plus plus as a as the exponent of PDF of Y curve is broken up into three parts. It follows that Z1 curve, Z2 curve, Z3 curve are independently normally distributed. Because this is the exponent part, so we see that this portion it is written as a sum of these three parts. Therefore Z1, Z2, Z3 are independently normally distributed. Okay. So under H naught, this nothing but a so I think there is a problem. Please give me 5 minutes. I will be back.